Hi everyone, this is Purnima working as an assistant professor in the Department of Tripling. And today in video lecture series, we are going to discuss about resistance series parallel circuits. So come, let's go on to the topic. So first, before going to the resistance series in parallel, we can see the basic elements of resistance series in parallel. So what is basically in circuit? Electric circuit provide a complete path for the current to flow. It is known as a circuit. And the basic circuit must includes power source, complete path, wires, and the load. It must have power source, complete path, and the load. So load may be resistive, light, and etc. And circuits may also include the control devices. And it is a protective devices. And now what components that the circuits belongs to? So the answer is load, path, source, and control. We have the load, we have the path, we have the source, and we have finally we have a control. Okay. Next thing is types of circuits. Here basically we have three types. One is series, next one is parallel, and both the combination of series and parallel circuits. We are categorized into three types. The series circuits. So there are the based on the path of current flow through it. So these categories based on the path of current flow through it. Here first, now we are going to discuss about series circuits. So allows only current flows through the one path from negative to positive throughout the load. Here from negative to the positive. Here the first thing is it flows through R3, R2, R1. Now only current only has one wave to go from one side of power source to another side. This circuit is known as series circuit. Now coming to the parallel circuit, it allows the multiple path from negative to positive through the flows through the load. So current can flows from different route from the source to load. So from source to load, it will be having more different number of paths. Okay. Now here the current now starts from the negative and first it flows through the resistor 1 and it closes the circuit. This is the first path. And second path, it flows from for the resistive 2 and close the path. And next path is it flows through resistive 3 and close the path. It has three different paths and it closes the circuits. So this circuit is known as a parallel circuit. Next is series parallel circuit. This contains of both the series and parallel circuit. Some sections allows the multiple path and some sections will allows the only one single path. It must have at least three loads. Okay, come let's go the path. So now the current starts from negative and it flows to the resistance R1, R2 and R4. This is one path and R1, R3, R4. This is second path. Now the resistance calculations. Coming to the resistance calculations, because some circuits allow the current to the multiple path, current division among of these paths, this reduce the total current of these sections. Therefore, different resistance formulas must be used for different circuits. So for different circuits, we have to use the different resistance formula. If it is series, we have to use some formula. If it is parallel, we have to use the formula changes. And for combination, we have to changes. Okay. Here we can see the series parallel combinations. Here, first, so only one path allows only one path. The total resistance equals sum of the individual resistance in series. The formula is R total is R1 plus R2 plus R3. Here the resistance R1 is 10 ohm, R2 is 20, R3 is 10 ohm. The total resistance R1 is RTH is R1 plus R2 plus R3, that is 10 plus 20 plus 30. 10 plus 20 plus 30. The total thing is 30, 40, 50. The R3 is 60. So 10, 20, so 10, 20, and this is 30. Okay, the total resistance is 60. Okay. Now coming to next parallel circuit. It allows the multiple path and the current is dividing among them and the total resistance is less. So the RTH is equal to R1 divided by R1 plus R2 plus R1 plus R2, 1 plus 1 divided by R2 plus 1 divided by R3. So that we have the value of R1, R2, R3. Next, see R1 is 1 divided by R1, R1 divided by R1, 1 divided by R2. Finally, we are applying the formula that we have getting the total resistance of 5.45 ohms. We are getting the total resistance of 5.45 ohms. Okay. Now we have only two resistor. Now we have only the two resistor. Now, but the two resistance is connected in parallel. Then how we are going to calculate? Let's see. Here, the two resistance, we multiply of two resistance divided by addition of two resistance. So this is the formula, multiply of two resistance divided by addition of two resistance. Here the formula differ for different circuits, different connections of circuit, whether it is series or parallel or only have two resistance. The formula differs according to the connections of circuits. And the total is, so here the R total is 10. Okay. Here again the all resistors are the same value. If the all resistors are the same value, then what happens? So it is divided by the total number of resistance. If all the resistance are same value, it is divided by total number of resistors. Here it is all resistance are same, hence it is divided by total number of resistors. Okay. Now the series parallel calculations. Here the connected series and parallel element and must have series and parallel formula, and we have here the example is, so R1, R2, R3, R4, we have both the series and parallel combination. First we have to concentrate at parallel connections, then we have to move on to the parallel series connections. Here, which is the parallel connection? This R2 is parallel with R3 and this R1 is also parallel with R2. Now let's see. First R1, R2. This first they are taking these two parallel connection and they are solving and they are finding that is it R total is 5. And now we can see this. Now let's see. So these two are parallel and by using this parallel we are finding that is almost 5. And now this circuit is redesigned into, so this resistor, this, so reduced into, sorry, redesigned, this circuit is reduced to 5 ohm and this resistance still R3 is 10 ohm and R4 is 10 ohm. So now this circuit is reduced to 4 resistance reduced to 3 resistance. Now this 3 resistors connected in series and we can have series parallel series formula and we can find the total equivalent resistor. Okay. Here the resistance formula flowchart. By calculating the total resistor formula, first identify the type of the circuit. First circuit is only, if it is series, only one path of the current flow and we have the formula for that. We will finish off with that. If it is parallel, we have to see the values. If the values are equal, then we are going for R equal, total number of resistance divided by total number of value of a resistance divided by total number of resistance. If no, we have to go for if there are more than 2 resistor, and yes, we have to move on for this formula. So if it is 2 resistor, we are going for this formula. And then third type is, if it is has both series and parallel, first we have to identify the parallel position and we have to sort out this, and then we are moving to the parallel series combination. This is the complete flowchart of resistance formula. Okay. Here we have a small practice. What kind of circuit is this? First thing, it's a series circuit and we are using the formula, and what does the total resistance is by adding of 3 resistors. And next, that is 150. And this is a parallel circuit and we are using this formula, and the 2 circuit we are using this formula and we are finding the total equivalent resistance. And this is the combination of series parallel. We are using these formulas and finding the total resistance, and the total resistance is based on the connections, it varies. Okay, I hope you understand what is series circuit, what is parallel circuit, and what is the series parallel circuit. We have different formulas for different connections, and with another topic we can see in next session. Thank you so much.